Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. So the only way of answering this question is to work out what these are as ordinary numbers. And so 7 times 10 to the power of 7 would be 7, 1, 2, 3, 4, 5, 6, 7. And 9 times 10 to the power of 4 would be 90,000. So that would be 9, 0, 0, 0, 0. And so we're just subtracting them like that. And so we'll get 6, 9, 9, 1, 0, 0, 0, 0. And obviously if this is on the calculator paper, just type it into your calculator. There are no tricks here. You can't do anything with the 7 and the 9. You're not subtracting powers or anything. You're just literally typing in what it says. And there's a button on the calculator like that that you will need to use. So if you don't know what that is, ask your teacher or ask someone to help you out with that. So we're going to start just by writing this out. So m equals 7 brackets x minus 10. And we're going to put our solving lines in. I'm going to start by expanding the brackets. And we don't need to. We could divide both sides by 7, but I think this is a bit easier. And we're going to subtract, or we're going to add 70 to both sides. So we're trying to get x as the subject. So we're trying to get x on its own. And we're next going to divide both sides by 7. So we have m plus 70, all of that over 7 equals x. So x equals m plus 70 over 7. So the first thing we're going to do is work out the area of the trapezium. And the formula for that is half brackets a plus b times h. Now a and b have to be the parallel sides. So here we've got the two parallel sides here. Just pick a different colour. Here and here. So that is a and b. And then the h is the perpendicular distance between them. So perpendicular means it hits it at right angles, so that's what we've got here. So the area would be half times A, which is 28, plus B, which is 14, times the height, which is 14. And so that would be 294. Next we'll do the circle. Now it doesn't look like we've got anything for the circle, but actually the height here is actually the height of the circle as well. So the height of the circle is the same as the diameter. So the diameter of the circle is 14. Therefore the radius would be half of that, which is 7. And the area of a circle is pi times the radius squared. So it would be pi times 7 squared, which will be 153.938 blah blah blah. Now keep that in my calculator, because next thing we'll do is the shaded area part, and it says we want to work out the area of the shaded region. So the area will be the total area, which will be the trapezium, take away the area that we don't want, which is this bit here, which will be the circle. So the trapezium's 294, the circle's 153.93 blah blah blah, and when you do that you get 140.061 blah blah blah. It says it wants it to 2 decimal places, so it would be 140.06. So for this frequency polygon, what we've got to do is work backwards to work out what the table was that created it. So we're going to just draw a starting of a table, and we're going to have our midpoint first, then our like money spent, our intervals, and then our frequency. So the first midpoint is at 40, and we can see here that that was, just get rid of that, that was between, like that was in this group here. So that is 0, and I'm just going to use M for money, 0 to 80, and the frequency is how high it is, which is 10. The next midpoint is here, so that was going to be 120. And we can see that that's between 80 and 160, and the frequency is 20. And finally the last midpoint is here, which is obviously 200, and that is between 160 and 240, and the height of it is going to be 7. So we're looking for the probability customer spent less than 160. So that is these two here. Okay, so there are 30 that are less than 160. And how many are there altogether? Well, it's that 10 plus the 20 plus the 7. So it's going to be over 37. So it's 30 over 37. I'm going to start by expanding these brackets. You could have divided both sides by 2 and then expanded the brackets on the left, but I'm just going to expand them all because it might be maybe easier, I don't know. So we've got 2x minus 44. Get our lines in because we're solving. And the rule is that we get rid of the smaller amount of x. So we've got 2x here and 12x on the other side. So we're going to subtract the 2x from both sides. And so that'll give us 10x minus 84 is less than minus 44. So we've got minus 44 there, but that won't be a problem because we're going to add 84 to both sides. And so we've got 10x is less than 40. And then we're going to divide 10 both sides to get what x is, or what x is less than, and that would be 4. So our answer is x is less than 4. There's a lot going on with this question, so I'm going to start off just having a look at the total amount of money. So I'm going to do this in pence, so 2,115 pence. And if each merit point is worth 3 pence, then we can work out the amount of merit points by doing 2,115 divided by 3. So that gives us 705. So there's 705 merit points. Next, have a look at the question here, this part here, where it says James has X merit points. Sarah has 4 times as many points as James, so she's going to have 4x. Robert has 69 fewer merit points than James, so he's going to have x minus 69. And we know that that equals 705 because we've just worked that out. And this feels like a solving coming on. So we've got x plus 4x plus x, which is 6x. Minus 69 equals 705. And we're going to add 69 to both sides. So we've got 6x equals 774. Then we're going to divide 6 both sides. And so we've got x equals 129. So x equals 129. That means James has 129. Sarah has 4 times more, so she will have 516. And Robert has 69 fewer, so we're going to take 69 away from that, and that will equal 60. So in this question we are told that the centre of enlargement is at 6, 4. So let's just put across there. And what I'm going to do is just draw ray lines from the centre of enlargement, and we're just going to go through each of the corners of our shape A. And we're going to just check whether it goes through the corner of shape B, which it does on this one. Let's just keep going. Yeah, it does on this one. But it does not on this one. So it says find the coordinate of the vertex of shape B that is not correct. So the coordinate is this one here, and so that would be -4, 1. So for this question we need to understand the different types of graphs from different functions. So if we have a reciprocal graph, it looks something like this and like this. It could be the other way around and it could be distorted, but it basically goes down to a point along here. It goes to infinity and it goes to infinity along a point over here, and obviously those positions could change. Then we've got a linear graph. A linear graph is just any straight line, so just any kind of straight line, either up or down, and this doesn't look like either of those. Then we've got a exponential graph. An exponential graph just starts really small and then just really increases like that and just keeps going up. And here we kind of have that, obviously the other way around, it starts going down, but here it's actually going up, so it can't be a reciprocal graph. So the graph that this is, or could be, is a quadratic graph, because it's a nice U shape. So if we carry this on, it could be a nice U shape. It could also be a cubic graph as well. So it could go up and then down and then up, and that's a cubic graph. But the most obvious one is a quadratic graph. So quadratic function. So we're going to go through this shape and work out the area of each of the shapes in the triangular base prism. So we're going to start with this triangle at the front. And the formula for working out the area of a triangle is half times the base, which is 12, times the height. And so that's going to be 54. Next thing I'm going to do is work out the rectangle here. And so the width of it's 23 and the length is 15. So we're going to do 23 times 15, which is 345. We're going to do the base of the triangle, or rectangle, sorry, at the bottom. And so that is going to be 23 times 12. And that is 276. And the next thing we're going to do is this rectangle at the back, which is going to be, I'm going to call D, and that is going to be 9 times the width, which is 23. So that's 207. Now we do have another triangle, but actually that's the same as A. So when we work out the surface area, we're going to do 2 lots of A plus B plus C plus D. And that gives us 936. So the answer is 936 centimeters squared. To find the gradient, we need to find 2 points we know on this graph. So I'm going to pick that coordinate and this coordinate here. And we know that we need to draw a right angled triangle between them. And we find the gradient by the change in y, which is 3, over the change in x. But notice the change in x is 1, so it's going to end up being 3 divided by 1, which is just 3. So a different definition of the gradient is for every 1 we go to the right, how far up we go, which is 3. If we try and visualize this question on a graph, then we've got C, which is somewhere here. So we've got C, which is somewhere here, at coordinates 2 minus 12. And we've got D, which is somewhere here, at coordinates 8, 4. And we're asked for the length of the line segment. So we're asked for this distance here. Now we can see that we can actually make a right angled triangle with this line segment. And we've got to find out what each of the sides is going to be. So the bottom one starts at x coordinate 2 and D it goes to x coordinate 8. So it's going to be 8 take away 2, which is going to be 6. So the distance there is 6. And how far does it go up? Well, we've gone from minus 12 to 4, so that's gone up 16. And we know that when we've got a right angled triangle, which this one is, and we're asked for one of the lengths, having given the other 2, we're going to be using Pythagoras. So for Pythagoras, label the sides A, B and C, with C being the one opposite the right angle. And we write down the Pythagoras' theorem, which is a squared plus b squared equals c squared. A squared we've said is 6, b is 16, and 6 squared plus 16 squared is going to be 292. And then we're just going to quickly solve this by square rooting both sides. And so we're left with 17.088 blah 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 is equal to C. And because it asks it to 2 decimal places, we're going to write the answer of 17.09. We can keep this as an interior angle, but it's actually sometimes easier to convert it to an exterior angle. And what you might know is that the sum of interior and exterior angles is going to be 180, because they will always form a straight line. So to find the exterior angle, all we need to do is 180 take away the 170, and that means it will be 10 degrees. So we've already done a different formula for exterior angle, which is 360 divided by n. And something we can do is we can just swap these two things around, and so we can make the formula that n equals 360 divided by the exterior angle. So 360 divided by the exterior angle, well, we know that the exterior angle is 10, therefore n is 360 divided by 10, which would be 36. So we're going to first of all convert the 11 litres into millilitres. So we're going to do 11 times 1,000, which would be 11,000. Okay, so we're going to just draw a line, like a number line. And we're going to have the 11,000 in the middle. Now, what would be the next one down if we're looking at to the nearest 10 mil? So we're going to add a 10 mil on, which will be 11,010, and we're going to take the 10 mil away. So 11,000 take away 10 mil will be 10. 990. Now when we're looking at limits with the upper and lower part of it, we are looking at halfway points. So halfway here and halfway here. So this halfway point will be 10,995, and the next one will be 11,005, and that's the halfway points. And so that is going to be our upper and lower bound. And we just need to say that V can be anything above the 10,995 and including that, and it can be anything below 11,005, but it can't include that, because if it did, if it was 11,005, it would have rounded up to 11,010. So this question is a simultaneous equations question, and so we're going to have to write down some equations. So it says 2 apples and 3 pears cost £3.80. So 2 apples, I'm going to call it A for the price of an apple, plus 3 pears, so 3p, cost £3.80. Now I'm going to do this as 380 just because it's easier to work with integers rather than decimals. And it says 3 apples, so 3a, plus 8 pears costs £7.80, or 780 pence. Okay, so the first thing I do is try and get these numbers the same. So 3 and 8, they both go into 24, so I need to make them both 24. And what some people do is they just label this A and this B. And so what we're going to do here is we're going to multiply everything in equation A by 8, so that this becomes 24. So it's going to become 8a. And so we're going to times the 2a by 8, which will be 16a, plus 24p, and 380 times 8 is 3040. And we're going to do the same with b, but this time we're going to times it by 3, so we're going to have 3b. and we're just going through everything here and we're timesing it by 3. So 9a plus 24p, which is good, that's what we wanted. And 780 times 3 is 2,340. So now we've got both of these the same coefficient. What we can do is we can eliminate going downwards. Now, if they are the same, the s in same is the s in subtract. If they were different signs, so if these weren't both positive, if one of them was negative, different, the d in different is the d in add. So here they are the same, so we are going to subtract, and we're going to subtract going downwards. So we're going to start off by doing, and I can just do a little line here to show what we're doing. So we're subtracting going downwards, and we're going to do 16a take away 9a, which will be 7a. 24p take away 24p, which is nothing, which is why we did that, is to eliminate them. And then 3040 take away 2340 will be 700. Then I can put my lines in, and all I need to do now is just divide both sides by 7, and I get a equals 100. So we know that apples cost 100, or £1. We need to work out what pears cost. So I just need to pick one of the equations. I'm just going to pick this top one here, and I'm going to write out. But instead of a, we know that a is a pound, or 100 pence. So plus 3p equals 380. So that's going to be 200 plus 3p is 380. And then again, I'm just going to draw my lines down. And we're going to subtract 200 from both sides. So it's going to be 3p equals 180. And then we're going to just divide by 3 both sides. And we've got p equals 60. So a pear costs 60. Now we can check this by using the other equation there. So 3 times 100 is 300, plus 8 lots of 60 is going to be, what's that, 480? So that's going to be 780. So we know that we've got it right. First thing we need to do is work out the volume of this prism, and it's a trapezium based prism. So the volume will be the area of the cross section, or area of the trapezium, times the length, how 3D the prism is. So trapezium is half a plus b h, and then times the length. Now a and b are the two parallel sides, which will be this one and this one, and then the h is the perpendicular line that hits both of them at 90 degrees, which is what perpendicular means, between the bases. So this will be the 25 meters here. So it's going to be half, and then we're going to add 1 and 5, times that by 25. The length is how 3D it is, so it would be that 10 there. So we're going to times that by 10, and that will give us 750. So it's 750 meters cubed. Now, there is a little formula we can make for the rate. So the rate of anything, for this, will be the volume gained over time. Now, with this question though, we're interested in the time it will take. It says how long will it take. So we're actually looking at the time. So it will be time equals the volume, which is 750, over the rate, which is 15. So 750 divided by 15 is 50. So it will take 50, and let's have a look. It says per minute. So it would be 50 minutes. So we're asked to find 3a minus 2b. So let's work out 3a first. 3a is going to be the top times 3 and the bottom times 3. So the top times 3 is 9, bottom times 3 is 6. Then we're going to work out what 2b is. Again, times the top by 2, times the bottom by 2. And so 3a take away 2b is going to be 3a, which is 9 at the top, take away, and then the 2b, which is minus 2. And then the bottom will be 6 take away minus 4. And so that's going to be 9 plus 2, which is 11. 6 plus 4, which is 10. So the vector is going to be 11 at the top, 10 at the bottom. We don't have to for this question, but it might be helpful to draw a Venn diagram for this. And we've got green and brown leaves. So we'll have green on the left and brown on the right. So green and brown. And we're told that there are 19 green and 15 brown and 6 that were not green and brown. So the only number we can put in is the 6 on the outside of the Venn diagram. We're told that 19 are green, but we don't know which, either they're in here or a bit of both. So what we can do is we can label the center X, and we can say that there are 19 take away X just green, because they could have been both green and brown. And for the brown we can do the same, so it'd be 15 minus X. And for the next step we know that all of them together add up to 32, because it says in the question. So we're going to add all of these, the 19 minus X, the X, the 15 minus X, and the 6 together, and we know that equals 32. And let's get our solving lines in. So we've got minus X and minus X, so that's be a minus X. And we've got 19 plus 15 plus 6, which will be 40, equals 32. We're going to take away the 40 both sides. And we can just times by minus 1 both sides to make them both positive. So now we know X is 8, we can start filling in the Venn diagram. So it's 19 take away 8, which will be 11. X is 8, so we know that that's 8. And 15 take away 8, which is 7. So find the amount that were green and brown. We know it's going to be 8. There's a lot going on with this question, so what I'm going to do is I'm going to put in all of the time signs that we don't normally show. So we've got 10 times 12x times y to the power 4 times 13 times x to the power 4 times y to the power 4. And I'm going to reorder these to put the numbers together, first of all. And with multiplying, it doesn't matter which way around you do it, so I'm not changing anything. I'm going to put the x's together. And I'm going to put the y's together. So, first thing to do is 9 times 13, which is just 117. Then we've got x to the power of 12 times x to the power of 4. Now we know when we multiply two powers of the same base, and the base is x on both of those, we just add the powers. So it's 12 plus 4, which is 16. So it'll be x to the power of 16. And then y to the power of 4 times y to the power of 4, we just add them together, so it's y to the power of 8. So we've got a right angle triangle here, and we've given two lengths and an angle, or it involves two lengths and angles. So that's going to be a trigonometry question. And to do trigonometry, we start off by labelling the side. So we've got the hypotenuse opposite the right angle. The opposite is opposite the marked angle, and the adjacent is between the right angle and the marked angle. And we notice that the opposite doesn't have a number or letter next to it, so we get rid of that. Next step is to draw in our triangles. So they are going to be saw, ca, toa. We've crossed out the O, so we can cross out the toa and the saw, and that leaves us with the ca. So write out the formula, which is cos x equals a over h. Now the angle is what x represents in our formula. So that's going to be cos 42 equals what a is represented with an x, and the hypotenuse is 7.3. So next we get our solving lines in. And notice, to get x on its own, what we're going to do is just times both sides by 7.3. And when we do that, 7.3 times cos 42, and be careful when you type in cos 42, close the brackets, then times it by 7.3. A lot of calculators open brackets when you type in sine, cos or tan. And we get 5.424 blah 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 equals x. So round to 2 decimal places, it will be 5.42. So we're going to first of all find out how many potatoes were below 22 grams. So we're going to draw a line up at 22 and a line across, and that is 13. So there are 13 potatoes below 22 grams. And so to work out the probability of picking one below 22 grams, it's the amount that we have below that amount, or below that weight, over the total amount of potatoes, which will be 20. So it'd be 13 over 20, which is equal to 65 over 100, so that would be 65%. I'm going to start by identifying the equations of each line. So here we've got y equals 2, because the y coordinate is always 2 on this line. This one here we've got x equals minus 3, because the x coordinate is always minus 3. And this next one is a bit more difficult, but it's perfectly diagonal, so it's going to be a y equals x line. But if you look, it crosses the y-axis at minus 1, so it's going to be y equals x minus 1. Okay, these are not inequalities though, so we need to work out what the inequalities are. So we're looking at the region which is here, and we can pick a point in the region. I normally try and pick a nice easy one, so let's pick 0, 4. So 0, 4 is in our region. So 0, 4, let's compare that to our y equals 2. Well, what is that compared to 2? Well, it's actually greater than 2, so it's y is greater than 2. We have a look at the fact that our line is dashed, it's not going to be equal to 2, because it's saying it's not on that line. Okay, this next one, let's have a look at this. Well, is it greater? Is that 0 greater than minus 3? Well, yes it is. So it's going to be x is greater than minus 3. Again, the line is dashed, so it can't be on the line. Now, this last one's a bit more difficult, because it's got x and y in it. So we feed in the values. So for our coordinate that we've picked, x is 0 and y is 4. So 4, and I'm just going to put, I don't know, not equal to, but or I'm just going to leave that blank, leave that as a box. And 0 minus 1. So all I've done is fed in the coordinate values into this equation. And I've got rid of the equals, because what we need to do is work out what inequality it's going to be. 0 take away 1 is minus 0. So what is 4 compared to minus 1? Well, 4 is definitely greater than minus 1. So it's going to be y is greater than x minus 1. But if you look, this line is solid. It's a solid line. It's not a dashed line. Therefore, we're going to put a little line underneath it, because it can equal it as well. We can write the equation of any linear graph as y equals mx plus c. So m is the gradient and c is the y-intercept. So we've got to find what the gradient and the y-intercept are. Well, I'm going to first of all try and figure out what the gradient is, because we're actually given some clues here. We're told that the line is perpendicular to the equation given. Now I'm going to rewrite this a little bit just to make it a bit clearer what the gradient of this is. So I'm going to write this as minus 1 over 12. I'm just going to leave a bit more of a gap there. Minus 1 over 12 x plus 12. And you can see that the number before the x, the coefficient of the x, is minus 1 over 12. But we're not told that it's parallel to that, so it's not, the equation that we've got is not going to have the gradient as minus 1 over 12. We're told it's perpendicular. Now, when two things are perpendicular, to find the gradient of the other one, if we know one of them, you've got to change the sign and find the reciprocal of the fraction. So to find our gradient, we're going to change the sign, so it's negative, so our gradient is going to be positive, and we're going to flip it. We're going to find the reciprocal. Reciprocal of 1 over 12 will be 12 over 1, or just 12. So the gradient of our line is going to be 12. To find the y-intercept, we're going to use the points given to us. So we've got x equals 3 and y equals 4 for a point on our line. We're going to substitute those into the equation we've got. So it's going to be 40 equals 12 times 3 plus c. Put in our solving lines. 12 times 3 is 36. And we're going to take away that 36 both sides. So it's going to be 4 equals c, or c equals 4. So our equation will be y equals 12x plus 4. We're going to start by working out what outcomes will give us two different types of drink. So we could have OA or AO. We could have AW or WA, and we could have OW or WO. Now what we notice really when we do this is that OA gives us the same probability as AO, same with AW and WA, same with OW and WO. So we're going to just ignore the right hand side ones, and we're just going to focus on the left hand side ones. To work out the probability of O and then A, so orange juice then apple juice, we work out the fact that it's 6 over, or the probability of picking orange juice first of all is 6 over 27. And then if we picked an orange juice, the probability of picking an apple juice would be 9 over 26. And so that would be 54 over 702. Apple juice then water would be 9 over 27, and then 12 over 26, and so that would be 108 over 702. And then orange juice then water will be 6 over 27 and 12 over 26, and that would be 72 over 702. Now we're looking at the probability of this or this or this, and the word or means add. So the probability of OA or, I should put that in brackets, probability of OA or AW or OW is these added together. And when you add them together, you get 234 over 702. Now, I said we would deal with the reverse situations now. I'm going to deal with that now. And as I said, OA is going to be equal to AO, AW is equal to WA, and OW is equal to WO. So all we need to do to find the probability that the drinks are different is get the 234 over 702 and just double it. And we can do that by just doubling the numerator, so 468 over 702. That cancels down to 2/3, so there is a 2/3 chance that the drinks will be different. I'm going to first of all just focus on this rectangle here, and we know that to find the area of a rectangle you multiply the two lengths. And when you've multiplied them for this rectangle, we get 697. But let's write down what A is equal to. And A will be equal to the area, which is 697, divided by the length at the top, which is x plus 30. Now let's focus on the other square, or the other rectangle. And this time we have A equal to the area of it, which is 1870, divided by the 10x. Now because both of these are equal to A, we can actually just get both of these fractions equal to each other. And what we can do is work out what x is going to be. So the first thing I'm going to do is I'm going to put my lines in because we are looking to solve. This is probably going to take a while. And I'm going to times both sides by the x plus 30, so I can get rid of the denominator on the left hand side. And so this will just be 697 on the left hand side, because that gets rid of the denominator, and it will be 1870 times x plus 30, and then all of that over 10x. Same thing again, but I'm going to get rid of the denominator on the right hand side, so I'm going to times both sides by 10x. So we've got 697 times 10, which would be 6,970x, because it's 10x. And it won't actually do anything to the right hand side, but I am going to expand the top, the numerator. It just gets rid of the denominator. So let's expand while I'm here. So that would be 1870x plus, was it 56,100? I believe that's right. Yep. Okay, so now we've got x's on both sides. So we look and see which one is the smaller amount of x, which is the 1870. And we're going to take that away from both sides. So take away 1870x from both sides. And that will leave 5100x on the left hand side. And then obviously we've got the 56,100 on the right hand side. And we want to get rid of the 5,100. So we're just going to divide both sides by 5,100. And so we've got x equals 11. So now we know x is 11, we can pick one of the equations that we had at the start, and I'm just going to pick the first one, and we can just feed in the value of x. So a equals 697 over, instead of x, it's going to be 11 plus 30. And when you do that, you get the answer of 17. So a is 17. So we're going to start by finding the multiplier. So we start off with 100%. It says it's decreasing at a rate of 8.1%. So we're going to take away the 8.1%. And then when we do that, we get 91.9%. Make that a multiplier by dividing it by 100, essentially making it a decimal. So whenever we get a number and we times it by 0.919, we're decreasing it by 8.1%. Now, there aren't any amounts given to us in this question, so we're just going to make one up. We're going to say that the population is 100, okay? And what we're going to do is type in 100 into our calculator, and then we're going to press the equals button. Now what that does is it stores the 100 in the calculator's memory. And it's basically, it's this next line that's the crucial bit. We're going to type in answer, which at the moment is that 100, times 0.919. And what that does is it says what the current answer is, we're going to decrease it by 8.1%. We're going to times it by that multiplier. And so every time we press the equals button, what it's going to do is it's just going to keep decreasing it by 8.1%. And we're going to count the amount of times we've got to press the equals button, because every time we press the equals button, it counts as a year. So when we first press it, it's going to be 91.9. Then press it again, it's going to be 84.4. So we're waiting for it to be beneath 43%. So if we started off with 100, we're looking for it to be below 43. So keep pressing it, keep pressing it. On the 9th year, we get 46.7, so that's close to that 43. Press it again, and we get 42.9. So it's 10 years. It's 10 times you've got to press it to get it beneath the 43. Okay, so we're going to start by creating a cuboid, just so we can kind of visualize what's going on a little bit easier. And so the lengths on the cuboid, it says, are 14, 10, and 8. Doesn't matter which way around. Now the longest part of the cuboid will be the diagonal across it. So if I just show a diagonal there, and it doesn't really matter which one we pick. Ooh. I could pick this one here, go diagonal like that. They're all the same length, all the diagonals across. So the rod will be, if it's the maximum length of the rod, it will be along this diagonal. So we can first of all have to work out what this length here will be, and then we can use the fact that this is 8 here and work out what the length of the diagonal is. So I'm going to call this x, and I'm going to call the diagonal y, just so we've got something to refer to in our working out. And it might be helpful that this side here is 10. So we've got a right angle triangle, because this is right angled here, and we're looking for the value of x. So we know that we're going to be using Pythagoras, because we've got 2 lengths and we're looking for a third length. So it's a squared plus b squared equals c squared. So it would be 10 squared plus 14 squared equals c squared. And it's actually not c, we've called it x, so why don't I stay consistent, equals x squared. So I'm going to do 100 plus 196, which would be 296 equals x squared. And get our lines in. Should be quite easy because we just need to square root both sides. So I'm just going to square root that, and we get an answer of 17.20 blah blah blah. Now I'm going to keep that value in the calculator itself, because I'm going to use that to find out what y is, our diagonal. So the next thing we're going to do is, we know what this is, and this creates a right angle triangle here, and so we're just going to do exactly the same thing again. A squared plus b squared equals c squared. Our a is 8, so 8 squared plus, and then we've got 17.20 blah 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 squared equals, and then we're looking for y, so y squared. Now if I square the value that's in my calculator from before, the 17.20, and if I just click square it, it will put it back to 296, because I've square rooted it and then I'm just squaring it again. So it would be 64 plus 296 equals y squared. So I'm just going to add them together, which will be 360. And again, I'm just going to put my solving lines in. Not too difficult to solve this. Make it a bit nicer, because I'm just going to square root both sides. So I'm going to square root this, and it gives me the answer of 18.9736 blah 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 equals y. Now it says it wants the answer to 2 decimal places, so it would be 18.97 to 2 decimal places. Now a different way we could have done this is we could have worked out y straight away by working out the, like, I don't know what to call them. I'm gonna label them A, B, and C. So A, B, and C. And what you can do is you can do the y squared equals a squared plus b squared plus c squared. It's basically the width squared plus the length squared plus the height squared. And so we would have had 14 squared plus 10 squared plus 8 squared. And when you've done that, you would have got 360, and this would be y squared equals. And then when I put the solving lines in, I would have done the same thing, square rooted both sides, and you obviously would get the 18.973 blah 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 again, and then you would have written down the answer. So there's 2 different ways of doing that. Obviously this way is a lot quicker, but you have to just remember that if you've got 3 lengths on the cuboid and you'll ask for the diagonal, then this formula here can be a much quicker way of finding the answer. So to find the shaded part of this diagram, we need to first of all work out the volume of the smaller cone, which is at the top, then work out the volume of the larger cone, which is the whole cone shown, and then take them away from each other. So the radius for the smaller cone is 4 and the height is 5. And the radius for the larger cone is 20 and the height is the 20 plus the 5, so it would be 25. So I'm just going to label them A and B. And so why don't we work out the volume for B first? And the formula for the volume of a cone is 1/3 pi r squared h, with h being the perpendicular height. So it's 1/3 times pi times 20 squared times 25, which is going to be 10,471.975, blah, blah, blah. We're going to work out the volume for A, and this time it will be 1/3 times pi times the radius now is 4, and the height is 5. So that will be 83.775, blah, blah, blah. So to work out the shaded bit, we're just going to do the volume for B, take away the volume for A. So it's going to be 10,471.975, take away 83.775. And all those I'm going to keep in the calculator to keep the accuracy. And that gives us 10,388.199, blah, blah, blah. And to 2 decimal places, it's going to be 10,388.20. So I'm going to first of all just draw out the diagram a bit bigger, just so we've got a bit more space. And we're looking at going from B to M, and M is about here. Now the first thing to notice with M, I'm just going to quickly label the other parts on, is that the ratio of A to M is 1 and M to C is 4. So the ratio is 1 to 4 between the two. And what is really helpful sometimes is just to label in the kind of section. So if A to M is one section, we've got 4 of the sections from M to C. So just put little notches there to show the 4 sections. And we can see straight away that A to M is 1/5 of that distance. That's why it's a nice, easy way to show that A to M is 1/5 of that distance. And let's just put a nicer 5, there we go. And so we're looking at going from B to M, but we can't go directly from B to M. We've got to go from B to A to M, and that's going to be the direction of travel. Now, we don't know the name of the road between A and M. In fact, we don't know the name of the road between A and C. We've got to first of all work out what that's called. So what we're going to do is we're going to go from A to C by going down here and then up here. So we can find out A to C is going to be going backwards down A, then up B. Now A to M is going to be 1/5 of A to C. Now if A to C is minus A plus B, that means A to M is going to be minus 1/5 A plus 1/5 B. Now we're asked for the vector B to M, and we know that that's going to be B to A plus A to M. We know B to A because it's labelled, it's just A. And we know A to M because we've worked it out down here. And it should be minus, let's get rid of that, because we know it's going to be minus 1/5 A plus 1/5 B. And so A minus 1/5 A is going to be 4/5 A. And then we've got the 1/5 B. So it's going to be 4/5 A plus 1/5 B. We're going to first of all work out what the function f g of x is. And to do that, what we're going to do is just feed in the value of gx. the function, the kx plus 2, we're going to feed that in as the value of x in the f of x function. So instead of 4x, it'll be 4 lots of kx plus 2 and then plus 3. Now this says that fg, when 4 is put into it, it gets an answer of 187. So when 4 is put into it, well, let's put that 4 into it. So 4 brackets, and it's k times 4, so that's 4k, plus 2, plus 3. And it says that that will equal 187. So we've actually got something we can solve here. So I'm just going to rewrite that, but actually I might expand the brackets as well while I'm at it. So 4 times 4k is 16k, 4 times 2 is 8, plus 3 equals 187, and let's get our solving lines in. Okay, so first thing we're going to do is, well, we can add the 8 and the 3 actually while we're here. So 16k plus 11 equals 187. So we're going to take away that 11 from both sides. So we've got 16k equals 176. And then we can divide by 16 both sides. So we've got k equals 11. So answer is 11. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.